And we're at 5, 4, 3, 2, 1. We're live. This is Retraice, segment number 68 for Friday, December 2nd, 2022, 11 p.m. Eastern, 8 p.m. Pacific. Retraice is about what's going on out there. The short answer to that is computer control. We're going to be talking about controlling computers today. I promise. Just want to make sure all of my things, I'm juggling a lot of things here, more than usual. What do we mean by computer control? I don't know. Go back. I can't. But Retraice is for outsiders. And outsiders are not players, and the computer control game is player-oriented. And so now we're trying to become players by maybe learning some AI. We're going to talk today about, we're still in the beginning of the AIMA4e project, Artificial Intelligence, a Modern Approach, 4th edition, Russell and Norvig. And we really landed on page 48 and said, if we're going to front load the math, front load the code so we don't get stuck in a proper study of this, we don't get stuck on things like how do we spin up a, environment, or how do we make some code do what we want it to do. We don't want to get tripped up by that stuff. And what does the symbol mean? We don't want to get tripped up. So we're front loading. This is the December to Remember sales event. We're selling only math and code this month. Page 48 is where it all starts. And we've gone through most of it, but the last thing we need to do is make our computer do the math for us. We don't need to exhaust the potential of doing math with our computer today. But we need to be in that mentality. And then there's one more step after that. We need to be in the, so if we're gonna be in the mentality of making computers do the heavy lifting for us, as long as we trust them. Trust is a separate subject. I could talk about it forever. You want me to? Should I start? No, I won't start. As long as we can trust the computers to do the heavy lifting, then we should make them do the heavy lifting. That's why we invented them and built them and improved them. But then we have to also consider not just the hardware and software that's at our disposal, but also the ideas, and in particular, the idea of an intelligent agent. Let's talk about that tomorrow, okay? One thing, amendments and corrections, Retraice number 67, yesterday's segment. I just want to be clear that a series is a sum of sequence elements. You would never say a finite. You would never say the series equals something. So it's like, think of the World Series in baseball. It's a thing. It's a collection of games. Whereas a sequence is like, the season's kind of a series as well. The point is, whenever you hear series in mathematics, you're talking about something that adds up to a number. And when you're talking about a sequence, you're talking about the elements that can be added together. Series are always made up of sequences or elements, but series are not themselves the sequence that they sum up into. Anyway, whatever, it's just math stuff. It's just, and the other thing, where should we do this? Let's look at this. Let's look at our notes from yesterday. You should always go to the notes if you're not sure about, if you're not sure about something that we talked about, or if you're not really sure that we quite nailed it, because it'll be better in the notes. I fix mistakes in the notes sometimes. Yesterday, I didn't make it clear enough when I was talking. I said at one point that this 30 was on an exponential curve. Basically, it is on an exponential curve. But the thing that we were talking about being the definition of the exponential function is this 2 raised to the 4, or a number of elements in a set raised to the t. That's the thing that explodes in the way that f of x equals 2x explodes. And then I had an equal sign here. It should be approximately equal to blah, blah, blah. Okay. Anyway, it doesn't matter. I just want to point out, go to the notes. That's always a good place to get the final word. I make the notes after the podcast. All right, shut up. Got to get to the thing. All right. So let's, the thing. No, that's not what we want. That's our script. Oh, geez. You've seen my secrets. Okay. So we're back to where we were yesterday. On the left-hand side, we're going to run code, and on the right-hand side, we're going to have something, basically a text document, to copy and paste it in. What are we trying to do? I should say that. We yesterday we did some math in our heads. We said, oh, what is each element, and then raised to the whatever, and then what does it add up to? 30, and then it's like, oh, I'll use a calculator to figure out like what is 3 to the 14 and all that stuff. Fine. But at the end of the day, we should be able to use the abundant tools of Python and any programming language that we choose to do that sort of stuff. And so we're going to do that today, quickly, not slowly. Okay, so one thing when we're working in Python, okay, the advantage of Python is that it's cutting edge and it's modern. It's like it's a language that's been invented in the last 20 years. A lot of languages have been, but they're not nearly as popular as Python. So it's very modern, and it's constantly being extended with all kinds of libraries and tools and stuff. The downside is that because it's moving so fast, because it's evolving so fast, you have to control it a little bit, or you're going to get error messages. This is what I'm trying to get to. You have to be ready for, or you have to try to avoid error messages as much as possible in the code that you write, but more importantly in your dependencies or as a result of your dependencies. So that's what we're going to do first here. Before we run this code, I'm just going to tell you one basic way of sort of avoiding a lot of this dependency hell that you might end up in. Okay, so let's have a look. On the left-hand side, you can see two directories, Re66 and Re68. Those have the code. This stuff's on GitHub, by the way, too, github.com/Retraice, as you'd expect. Okay. That last directory, venv-re, that's my virtual environment for Python packages. Okay, so this is all explained in the readme.org, and it'll eventually be in the readme.markdown.md. But just suffice it to say, we're going to, instead of just running IPython here, we're going to start a virtual environment first by typing this venv-re, come on, bin activate. And that's just like a little shell script that does what we want. Anyway, this is controlling what we do so that we can, okay, so not controlling what we do, it's controlling what packages are installed with Python. And let's do, actually, the org. Let's just look at it for a second here. Okay, so what I'm talking about is, let's do that too. Deactivate. I know you don't know what I'm doing here, but just bear with me. Okay, trust me. You are gonna wait. Just listen. You are going to have terrible experiences if you don't heed my warnings. Okay? Sometimes you have to heed. And the terrible experiences are going to be, I typed it the way he said it and it didn't work. I copied and pasted his code in my code, and my code doesn't work. It's broke. Yeah, you're going to be like that. You're going to be that guy or gal. You're going to be that. If you don't just, when I start talking about something like this, you got to listen. Listen. It's not always fun. Okay. So I'm in where am I? CD. Okay, so we'll do it up here in the parent, the AIMA directory. Okay, so first I want to show you that I'm using a Python. Oh, come on. I'm terrible when that's not supposed to happen. That completion thing's not supposed to happen. But it doesn't matter. There's something wrong, but it doesn't matter. There's a way around it. Okay, so what I've just okay, let's do this again. What I'm showing here is that I'm using PyEnv, the program called PyEnv, which I got from Homebrew, because I'm on a Mac, but you can do this stuff anywhere. And it's showing that we have the system installation of Python and and then we have another installation, version 3.10.6, and that's my PyEnv version. And if I just want to make sure, so that's the version of Python. So if I go Python version 3.10.6. Okay, you want those two to match. You want to make sure that, and I've set it to global, so but you can use different versions of Python for different projects. The point of the reason you would want to use different versions of Python, or the main reason, is that you're working on different projects. You're doing things in the real world. You're not just fiddling at home, and you can build a whole project around Python 3.09.1, and then they make some change, and you upgrade to the latest Python, then you run your old project, it doesn't work anymore, or there's some bug. Backtrace, you'll get these horrible error messages, and it'll take you forever to figure out that it wasn't your fault. You have to first put Python itself in an environment, and then within that, we're going to put Python packages in their own environment on a project-by-project basis. You can learn all this by Googling it, but I'm just telling you, save yourself a lot of grief, or don't use Python. But Python's amazing. You can use other languages that are that aren't evolving as quickly. But why? Just do what I'm telling you. Okay, so I'm using pyenv to control my Python version. Okay, that's all I wanted to establish there. And then to create this virtual environment that I'm going to jump over into for the Python packages, I just entered this little command, Python -m venv. Venv is now virtual env is very similar, but venv is the virtual environment tool that ships with Python. You can use pipenv, you can use virtualenv. There are arguments in play going around for all of them, but venv is the one that's installed, so that ships with Python. You don't have to add anything. So I decided for our purposes today, we're going to use that. So I've already done that. So I've already executed that thing in blue there, that command to create the virtual environment. And then just to start the virtual environment, we just type. I can never think of a good name for my virtual environment directory. I never like the names I come up with. They're always they require too much typing. All I'm going to do here, if you just look, this thing that you're looking at here is the let's see. So I just printed to the screen in sort of a colorified way this activate file. It's just a shell script. It just does sort of common sense stuff. But it does what it changes your command line environment so that it can control what packages in sort of a predictable and sustainable way, what packages you install when you're using a Python, when you're building something in Python. Okay, so let's source that so that now we get this little thing over here that tells us we're in the venv environment, which is what we want, and now we're ready. Now we're in business. And the reason I had to do that is because there was in another. We're not going to use it today. I was like, why'd you explain all this? We're not actually going to depend on this. Shut up. I started using someone else's code. Where is he? This guy. Doing math with Python. This is awesome. What's his name? Saha. I thought I was going to do some pretty printing and stuff to the screen, but I decided it wasn't necessary. And so I'm not going to use this code, but I started out. But then you needed to import a Python module. And when I did that, I knew, okay, I'm not creating sort of a future situation where I can run this code again unless I put it in an environment. So I put it in an environment. And then as soon as I did that, I decided I didn't need it. Okay, so we're back to the screen here, and this is all done. So we're going to cd to the directory for what we're doing today. And let's look at what we want. Oh, I've got an environment for that one too. Okay, I got to go over and do that. Oh, I've got two environments. I don't need that. Exit. Okay, deactivate. Deactivates my environment, cd to 68. And now we're going to do this 68 environment. What is it? Yeah, there we go. There we go. Action packed, huh? So now we are in the place we want to be. Let's fold all of this because it's kind of like what I said, but this will all be online. You know, if you ever I don't want people to get stuck with the basics, so I'm putting it in there in the notes if you need it. And fold. No. What did I forgot what my fold thing is. Fold region. No, it's not that. Darn it. I tried to create a key binding, but I've forgotten already. Okay. There should be one built in. All right. And then this is the code that I didn't use. So I'm going to just fold that as well. What the heck is my... Okay, we just need to do this. Okay, I'll show you how I do this. So cat.emac... no. Jeez. Man, I am off my game. Okay, we're going to do that, and then we're going to grep for the word fold, and my key binding is, oh yeah, I just made it easier. Okay. Yeah. Okay, let's test it. I don't know if I should be doing this, but I'm doing it. So it's just that. Yeah, it's just open bracket F with the control. I made it easier and then I forgot it. Okay, I got to learn that one. And we'll just go over here because this is going to sit open and we're going to keep switching to it annoyingly. Okay. Let's fold some even more stuff. Too much. No, not. Okay, perfect. Okay, so here's the first most basic. This is not the most basic way. This is the most commonsensical way. Okay, to do what? Jeez. Okay, let's go to bang. What do we want to do? We want to calculate. Oh man, I'm learning new skills here. We want to calculate something like this, or even better, an algebraic form where we can plug in the values using a computer program. That's what we're doing. Okay. This is yesterday's notes. Go check them out. Okay. And then, like I said, the stuff's on GitHub. This is what it looks like on GitHub. You go to github.com, Retraice, and you'll see exactly the stuff that I'm going to be looking at on the right-hand side of my screen. The stuff I just folded is here. This is the thing we're just about to talk about. And then the other things, oh, I spoiled it. Okay, but I'm going to close it because I keep switching to it by accident. Okay. So now we go back to the terminal, and I go back to the terminal. We have to do both things at once. Okay. Let's copy that. Let's go over here and go into IPython and clear the screen and paste it. Okay, so what are we looking at here? This just is another function, print series function. It takes two arguments, number of percepts and lifetime of the agent. And remember, we're trying to calculate how many entries should be in our lookup table. I don't know if I said that today, but I said it a lot yesterday. So this function is designed to calculate how many entries we have in our lookup table. So the first thing it does is it sets a variable called series equal to the number of percepts raised to the 1 power, so basically to itself. That it gets the number of percepts up here, and it just does a little bit of arithmetic. Then it does a for loop. It says for I in range 2 to lifetime plus 1. I know that's kind of funny. Math and code are like that. Sometimes you have to sort of fence post things and stagger them to get the result that you want. I think that Python for loops are not inclusive, so I think when it tests for the upper limit of the range, which is lifetime here, if it's true, then it doesn't do the for loop. Or you know, it doesn't anyway. That's why you have to do a +1. So, and we're starting with 2 because because we've already done 1 here. Don't worry, this is going to make more sense when you see the expanded version. Okay, so then the for loop says for each index in between 2 and the lifetime of the agent. In our case, the first one we're going to do, the lifetime of the agent is 4. So between 2 and 5, non-inclusive, or from 2 to 4, 2, 3, 4, it's going to set the series equal to itself plus the number of percepts raised to the ith power. Now, remember, a series is a sum of something. So when we see a series set equal to itself plus something, it means we're making it bigger by whatever the something is. Okay, that's all that's doing. And it's going to keep doing that over and over again in a for loop until the index value, the I value, reaches lifetime plus 1. I know this is, okay. Anyway, and then once the for loop is done, I just want to print the series. That's what this is. All right, let's watch it so we can learn what the heck I just said. Print series. And the other thing I can do here is I can name these arguments, these keyword arguments explicitly up here. So there are 2 ways. Let's start with the number of percepts, and our lifetime is going to be, as it was in our agent yesterday, this should evaluate to 30. Bang. Okay? It doesn't prove that the code is correct, but that is exactly what we wanted it to say. What are we talking about? We're talking about that right there. Those 4 elements. You got 2 possible percepts in our environment, 4 steps in the lifetime of the agent, or 4 percept events means you need 30 entries in your lookup table. That's all we just did. That's the arithmetic that we just did using a program. The nice thing about programming it is, first of all, if you trust your software and you trust yourself, if you wrote it, and you trust your hardware, you have to trust everything, then you don't have to do all the arithmetic. But if you don't, you have to do some arithmetic to sanity check or get some sort of formal proof or something like that. Okay, let's change the lifetime of the agent to 3. Not 3, 5. Ooh, okay. Well, what did it do? So it took let's go over here. Okay, so picture that sequence, the series, including the sequence. I'm going to try and jump. Oh, man, I thought this would be easier. Okay. So what we just did is we added a term. The lifetime is now 5. So what would the term look like if it were here? It would be 2 to the 5. 2 to the 5 is, what, 32? 32, right? 2 to the 5 is 32. 2 to the 4 is 16 because it's 2 times 2 squared. And then 16 times 2 is 32. So our program is looking pretty healthy, okay? If we look over here, the lifetime is 5. It should have added to our previous lifetime of 4. It should have added the number of percepts squared. So our number of percepts was not squared, raised to the fifth power, raised to the final power. So that was 2 to the 5, which is 16, which is 32. And that's what it did. 30 plus 32 is 62. And then we can go on and on like this. So this is that last term is exponential. What if we go, yesterday I said above about 14. Let's call that big. Okay. Now that number, so what we just added is our 16,000 whatever, but we added it to a previous sum. It's more than 16,000. So if we go over to, come on, there we go. We said yesterday that it gets big for f of x equals 16, roughly 16,000, when 2 is raised to the 14th power. It's not 16. It's more than 16,000. I said roughly 16,000. But what is that 16,000? It's the last term in the sequence. Okay, so that's being added to all the other terms, and it's, in our case, it's easy. We only have 2 percepts, so it's doubling. So we can see sort of more or less obviously that we added a number double this, double what. Well, let's look at it precisely. Let's say 13. What is it? Okay, so 16. Man, they messed up the calculator in here. 2 times 2, 16. Come on, man. You got to be kidding me. Nothing's going right today. Oh my goodness. Okay, 16,382 times 2 is 32768. Yes. Okay. That's good. I'm glad that's good because I was afraid it was going to be wrong. Okay. Let's talk for a second. I'm going to show you, I'm going to talk about the 16,000. I'm going to talk about I don't know what I'm going to talk about. Yeah, no, that's right. I'll do it. Okay. Mixing the math. Okay. We're doing math and code together. That's what we wanted to do. We spent some time on the code. We spent some time on the math. Now we want machines to do our math for us. But you also want a podcaster who's a little bit better at doing this than I am. And you've got one, but he lives 2 to 3 weeks in the future. All there is here today is me. Okay. So the last term of our sequence is always going to be like, it is double what the previous term was, but it's not going to be double what the whole sequence was, the whole series of the previous terms, because you're adding them.